In this question, we have two containers of gas. So we have container 1 and container 2. Container 1 contains 1 mole of hydrogen, H2 gas, at 310 Kelvin and 1.4 atm. We're told hydrogen has a molar mass of 2.02 grams per mole. Okay, then let's look at container 2. Container 2 also contains 1 mole, but this time it's of nitrogen N2 gas. It's also at a temperature of 310 Kelvin and also at a pressure of 1.4 atm. We're told nitrogen has a molar mass of 28.02 grams per mole. We're also given this graph of the number of molecules against the speed, also known as a Boltzmann distribution. And we're told down here the distribution of speeds of the particles in container 1 is shown by the blue line. So here's the blue line on the graph. That is container 1, which is the hydrogen gas. So let's just label on there. That is the hydrogen gas, H2, is the blue line. And our goal is to figure out which of these lines represents container 2, which is nitrogen N2 gas. Is it the green line or the orange line or the blue line? Okay, so first let's compare our two containers. First with the temperature. Both of them are at 310 Kelvin. So which container is at a higher temperature? That's going to be equal. Both of them have the same temperature. Our next question is asking about average kinetic energy. Which container contains particles with the greater average kinetic energy? Now, temperature is directly proportional to the kinetic energy of our particles. So if we have a higher temperature, we have a higher average kinetic energy. A lower temperature, a lower average kinetic energy. In this question, we have equal temperature in our two containers, so our average kinetic energy must be equal. Okay. Next question asks, which container contains particles with a greater mass? Now we know from the question nitrogen N2 has a molar mass of 28.02, which is greater than the molar mass of hydrogen H2, which is 2.02 grams per mole. So container 2 contains particles with a greater mass. Finally, it asks us which container contains particles with a greater average velocity. Okay. So now let's think about what kinetic energy means. Kinetic energy is to do with both the mass of our particles and the velocity or the speed. The equation for kinetic energy is half mv squared, half times the mass times the velocity squared. So both mass and velocity affect kinetic energy. Now we know the kinetic energy is equal for container 1 and container 2, but we know that container 2 has a greater mass of particles. So if container 2 has a greater mass but equal kinetic energy, the particles must have a smaller or slower velocity so that when we multiply them together, we still get the same kinetic energy. So we know that container 1 must have particles with a greater velocity because we know they have the same kinetic energy overall in each container. So if one has a greater mass of particles, the other one must have a greater average velocity of particles to balance out and give the same kinetic energy. Okay, so finally looking at our graph. This graph is of the number of molecules and the speed. So if we have a greater average velocity for container 1, that means our average speed, which we can think of kind of by looking at the peak of our graph, our average speed is going to be higher for container 1 because it has greater average velocity, and it's going to be lower for container 2. So that means that this green graph, this is the one that has a lower average speed compared with our blue graph, which is for hydrogen. So this one must be the one that's for nitrogen. The orange graph, on the other hand, shows a higher average speed. So that can't be the correct one. So the answer is going to be green. That's our graph representing container 2.